In the Cerrejón region of Colombia, a team of scientists and paleontologists was digging deep into the ground in a coal mine. This coal mine was actually formed from a 60-million-year-old rainforest. That's why they were searching for the remains of ancient plants and animals. This place was part of a mysterious past hidden from the world, which the Earth had concealed within its layers. During the excavation, experts found a strange object deep within the rocks. When the soil was removed from it, it turned out to be nothing other than a bone. Some said it was a crocodile bone, some called it a turtle bone, while others thought it was the trunk of an ancient tree. But this bone later took science on a journey to a world where the largest snake ever lived, Titanoboa. This was no ordinary snake. It was 10 times heavier than today's green anaconda and longer than a passenger bus. It was so heavy that if it tried to crawl on land, it would die under its own weight. So, where did it actually move? A simple bone led experts to a history of the Amazon where the map was completely different. What was the real reason for Titanoboa's immense size? How did it hunt, and what finally happened that ended its reign in the Amazon jungles? Welcome back once again to ZMTV Videos, Nazreen. The discovery of Titanoboa was not a sudden event. It began in 1994 when a local geologist, Henry Garcia, saw a strange object in the Cerrejón mine that looked like part of a tree branch. At the time, no one paid much attention, and it was stored in a special box. Nearly a decade later, in 2002, another geologist, Fabiani Herrera, found a similar fossil from the same area. These geologists were actually researching ancient flora to understand what the world's first tropical rainforests looked like. The real twist in this story came in 2007 when these fossils were sent to the Florida Museum of Natural History. There, it was discovered that it was neither a tree branch nor did its structure match a crocodile's spine. But when they compared its structure to the bones of today's anacondas and pythons, the surprise was boundless. This bone was 3 times larger and thicker than an anaconda's bone. At this point, experts immediately identified it as a snake's bone. You can imagine. On the right side is the bone found in the coal mine, and on the left is an anaconda's spine bone. In the world of science, size matters a lot, and Titanoboa broke every previous record. Experts used mathematical models based on this spine bone to estimate the snake's length. They observed that in snakes, the size of the spine bone is directly proportional to their total length. That is, the size of the snake's spine bone can indicate its total length. Calculations based on the discovered spine bone suggested the snake's size was 42 to 50 feet, about twice as long as today's anaconda. Titanoboa was not just long, its thickness was like a stout man's waist, and its weight was so immense that it equaled a sedan car, about 1,200 kilograms, or 10 times heavier than an anaconda. A weight of 1.2 tons is impossible for any land snake today. This discovery caused a worldwide sensation because this was truly the king of snakes, later named Titanoboa. The real question wasn't how big it was, but why it was so big. Why don't snakes today grow that large? The answer lies in the climate. Snakes are ectothermic, or cold-blooded animals. Humans can generate heat internally to keep their bodies warm, but snakes depend on the environment's temperature for their warmth. A simple principle of biology is that the warmer the environment, the faster the metabolism of cold-blooded animals. Faster metabolism means more strength, better digestion of food, faster growth, and the ability to sustain a larger body. The discovery of Titanoboa presented experts not just with a new snake but also a thermometer of that era's climate. Titanoboa's massive body was living proof that 60 million years ago, the temperature in this region of Colombia was much higher than today. During that period, Earth's climate was so warm that temperatures remained above 32 degrees Celsius year-round, day and night. If the average temperature was that high, humidity would have been extreme, so much so that breathing might have felt heavy. This was dense forest that never cooled down. This constant heat gave Titanoboa the ability to grow so large. Today's Amazon rainforest, which feels quite humid and warm to us, might have been too cold for Titanoboa. If it were alive today, it likely couldn't survive in this rainforest because the energy required to sustain such a heavy body was only possible in that intense heat. Now, obviously, to keep such a large body alive, it would need an equally large amount of food. The question arises: how did Titanoboa hunt? Did it slither rapidly on land like the monsters in Hollywood movies, chasing its prey? Absolutely not. Such a large and heavy body would have found it difficult even to crawl on land, let alone hunt. Gravity worked against its weight. The longer a snake is, the more it clings to the ground, meaning more friction. Research revealed that Titanoboa was very sluggish. That's why it was not a land hunter but an aquatic predator. It behaved much like today's crocodile. It spent most of its time in swampy water because the water supported its heavy body, allowing it to float and reduce the feeling of weight with the help of buoyancy, enabling it to move with agility. In deep swampy areas, it would lie in ambush, with only its eyes and nose visible above the water. It was an ambush predator, meaning it attacked by lying in wait. It didn't chase its prey but waited patiently in ambush for long periods, hours, maybe even days, without moving. Its body camouflaged with the water's color so well that prey wouldn't even realize its presence. And as soon as an animal came to the shore to drink water, Titanoboa would strike with lightning speed. Scientists have estimated through biomechanical models that when Titanoboa constricted its prey, it exerted pressure of over 400 psi. This pressure is so immense that it's like two African elephants standing on your chest. Titanoboa didn't wait for its prey to suffocate. Such pressure would directly break its bones and stop blood circulation instantly, ending the prey in the blink of an eye. But what did it eat? To sustain such a massive body, it needed a lot of food. In this tropical forest 60 million years ago, Titanoboa's favorite food included large turtles and ancient crocodiles. Yes, during that era, there were turtles over 8 feet in size, as big as a snooker table. Titanoboa could clamp such turtles in its jaws and tear through their hard shells. Its teeth weren't designed for catching fish but for crushing thick bones. Similarly, the crocodiles that rule the jungle ponds today were smaller compared to the crocodiles Titanoboa preyed upon. All these facts indicate that Titanoboa was the predator of predators and the unmatched king of the Amazon in its era. Now, you might wonder, if its thickness was like a healthy human's waist, how did it eat such a large turtle? Let me tell you. In snake discoveries, the biggest challenge is finding their skull. A snake's skull is made of very delicate bones that break easily after death. For the first few years after Titanoboa's discovery, experts only had spine bones, which made it difficult to accurately estimate its face and hunting methods. But then, in 2011, an intern, Jorge Moreno Bernal, found Titanoboa's skull in Sarajevo. This was a once-in-a-lifetime discovery. This skull proved that its jaw could dislocate like an anaconda's, allowing it to swallow things 3 times larger than its head. Its brain was very small, but its senses were sharp. It had pit organs that could detect the body heat of other animals, enabling it to hunt in the dark. Remember, water was not just a hunting medium for Titanoboa, it was also essential for its life. Such a large body, if fully on land, would collapse under its own weight, and its internal organs would rupture. Water supported it, helping to lighten its load. Thus, Titanoboa's life was a perfect balance. Heat gave it strength, and water reduced its weight. It was a wonder of nature, perfectly adapted to its environment. But the question arises: if it was so perfect, so powerful, and had no predatory enemies, How did this king of the jungles disappear? Why don't we see them today? The answer is simple yet heartbreaking. The world changed, but Titanoboa couldn't adapt in the same way. After the Paleocene era, the Earth's climate gradually began to cool. For us humans, a few degrees of temperature change might seem trivial, but for a cold-blooded giant, it was a death sentence. As you learned earlier, Titanoboa's metabolism depended on environmental heat. When the cold set in, its metabolism slowed down. Its digestion process became longer, and its strength diminished. It was no longer as agile, nor could it easily catch prey. It wasn't just the drop in temperature, the entire ecosystem changed. The swampy areas, perfect for Titanoboa's habitat, slowly dried up. As swamps reduced, the final nail in the coffin was driven by mammals. Mammals began to proliferate worldwide, and the prey that once belonged to Titanoboa was now divided among other animals. Gradually, everything became insufficient for the world's largest snake. No swamps, no warm climate, and no prey. Just a few degrees of cooler climate turned the world's largest snake into a part of history. Hope you'll like and share this Journey Unlocked video as well. Thank you so much for your loving comments.